Hey, what's going on? So, I am finally going to finish this topology by showing you how to configure the server switch and the three servers hanging off of it. I think it's been roughly, I don't know, give or take 3 years about since I did this. Let's see, 2015. Yeah, it's been about 3 years since I just stopped making videos on this topology. And today is actually my first time really coming back to it lately, so I'm pretty much looking at this through fresh eyes. I have a pretty good idea of what I did and what we configured in the other videos, but it's been so long since I've seen them, I don't really remember. So I'm probably going to be stumbling around a lot today, but hopefully I can show you how to configure NTP, Syslog, and DHCP on these servers. I do want to show you how to configure VoIP. That one I'm definitely going to probably struggle through. I don't know if I'm going to hit that in this video or not. Hopefully I'll actually make another video that shows you how to put the configurations on the VoIP router, that 2811. But, I mean, it's been so long since I've touched this, but I guess better late than never. So let's just get into this. A few little things here. I noticed that I had this note from before where our goal was to have only management access and this username password, and I had some IPs for the NTP server and Syslog, as well as no CDP on the trunks. But I'm actually going to change this config, and let me see if I can get a whiteboard thing going here. Okay, see if I remember how to use this. So instead of NTP server being 130 and Syslog being 131, we're going to actually configure HSRP on these two core nodes because it has two links down to our server switch. So just to kind of give our server area some high uptime capability, we're going to be using HSRP up here in the core as well, so that all of the servers will have a virtual IP for a default gateway. So if one of these core nodes was for some reason just shit the bed, people could still access the servers. So the default gateway is going to be .129. So the subnet that I was using for the server VLAN, well, it's not a VLAN, but the server network was this 5.0.0.128. So 129 is going to be our default gateway, with 130 and 131 being our actual interface IPs for the core. Now, if you haven't set up HSRP, go back a few videos. I know I talked through how to set up HSRP down here in the distribution layer. So I'm not really going to be going over that very much here. So the first thing, and here's where I'm going to get confused. Where do we start? I guess we should start on the core layer. So let's just go ahead and configure up HSRP and the networks, and I'm going to make sure that the interfaces are at least there and connected for this server switch. I don't remember where I did this, so fast Ethernet 03 to 01, and 03 to 02 it looks like. So on our whatever switch this is, core switch 2, which I guess we never put a host name on, I'm going to go ahead and do that right now. Configure terminal, host name, core 2, and I'm going to do a show run. I'm going to look at fast Ethernet 03, so we already got an IP on it. It's 131 /28 with that mask. So let's go into that interface, fast Ethernet 03, and let's assign it a standby group, and I'm just going to use standby 99. That sounds good. So standby 99 IP 5.0.0.129. Is there anything else after that? Nope. And I'm going to give it a priority of, it's been a while since I studied my priorities, but 55 sounds good. And standby 99 preempt, so that it'll overthrow the active router, or the other router, if it has a lower priority, or the less desirable priority, I guess I should say. I don't really remember the whole priority thing. I haven't configured HSRP in a while. Alright, so now going on to core 1. Let's go into interface fast Ethernet 03. Well, I guess we should do it. So fast Ethernet 03 on core 1. Looks like we got the 130 IP already there, so shouldn't have to do anything except put HSRP on here. So standby, make sure it's in the same standby group. Standby 99 IP 5.0.0.129. Standby 99 preempt, and standby. Oh, we're not going to do a priority on this one. We'll leave it default. So write that. And just on both of these to verify that HSRP is running, we're going to do a show standby brief. Do show standby brief. Looks like core 2 is our standby, and yep, core 1 is our active. So HSRP is working now, and we're just going to keep the server switch at default configs. We could set up the management VLAN, I guess, but for now I'm just going to leave it blank. It's just straight layer 2 blank configs. So each of these servers is going to have their default gateway pointing to our virtual IP on the core nodes. So let's start setting these up. So the first one, let's make this one NTP, just whatever. We'll do 5.0.0. Let's see, 130 and 131 are our physical IPs for the core. So we'll start this out at 130. Let's start out at 135 just to be safe. And subnet mask for a /28 is 255.240, and our default gateway 5.0.0.129. And we don't need to worry about a DNS server. I don't know, did I do a DNS server? No, I guess I did. Let's just see what the IP of this guy is. 10.10.4.1. And we'll put that in here anyway. 10.10.4.1. Doesn't matter. That is not a configuration we need at all for NTP to work, but I like to keep my labs consistent. So the first thing, we're going to go down to the NTP tab in the services area of the server, and we're going to enable it, and we're going to say key number 1, and let's just make the password Cisco. So this is the authentication that we're going to have to configure on our network devices in order to connect to the NTP server. Now we could leave this disabled, and then just our NTP configuration will be free. Anyone could connect to our server, but if there's the option for authentication, you should probably take it. So we've got our IP set up, NTP is configured. Let's just go down to a random PC here, and I know we haven't set up DHCP yet, so I'm going to throw a static IP on this guy, 5.0.0.35. Address is already used on the network. Okay, 5.0.0.40. And default gateway 5.0.0. I assume I used the first available IP in the network, so 33. Let's just see if we can ping our default gateway. And we can, so I was right on that. So let's see if we can ping our NTP server down from the access layer. So 5.0.0.135. First ping usually fails by default, but yep, there we go. So we can ping our NTP server now. So let's start configuring our network devices to pull time from NTP. So let's just do a show clock so we can see what the time is right now. It looks like we're back in 1993. So once we sync with the NTP server, this should change to the current date. And the way we do this is pretty simple commands, just NTP. We'll do a question mark, see what our options are. We got authenticate, authentication key, master server, trusted key, and update calendar. So the commands we're going to be doing is authenticate, authentication key, server, and trusted key. Those are the 4 we need for a client. We're not going to use the master command because we would only use the master command if we were configuring a network device to be an NTP server. But right now we've got our server device as the NTP server, so we don't need to configure any of our network devices as master because the server is our master technically right now. So NTP server, we'll put in the IP of the server, so 135. And we're going to do key 1. Oh, yeah, key 1. So the phrase key 1 after the IP specifies which key you're going to use to authenticate. And to configure that key, you do NTP authentication. Oh, these are both. I hate it when you got two that are the same. AUTHENTICATION. Key. There we go. Key number 1. MD5, because that's our only option. And the authentication key, which we defined as Cisco. And then you got an authentication key encryption type, and we're going to leave that out. We can finish the command right there. So now we've got our server with a key number, and we've defined our key, but we have not yet told this device to actually authenticate with NTP. And we do that with just NTP authenticate. And then one last step that I don't like, I don't know why this is a thing, but we have to do NTP trusted key and our key we're going to use, key number 1. Apparently, if you don't define the trusted key, it won't authenticate properly. I don't remember what exactly it was, but you have to tell NTP to use a key, you have to define the key, you have to tell NTP to authenticate, and then you have to tell it which key is trusted to authenticate with. It's kind of redundant, I think. I know there's a reason for it. Don't remember the exact reason, but you have to do both trusted key and authenticate. So now if we do a show clock, well, our clock is still back in 1993. So let's do a show NTP status, and we get a bunch of output. And the part we're really going to look at, I mean, it says it's still Stratum 16, so that's kind of a giveaway. Unsynchronized, that's another dead giveaway that this NTP configuration isn't working. So if we do a show NTP associations, this should show which servers we're associated with and syncing with. So here we got our 5.0.0.135, and you can see that we got the little squiggly line in front of it, which means that it's configured. But we are not peered with it. We have not got time from it. Nothing has happened. What you really want to see is this star ahead of your server address. If it's not there, it is not synced. Now, one thing we're going to check here is just make sure we can ping the NTP server from the switch. We can. So we're just going to wait on it to sync. Sometimes NTP takes forever. So while we're waiting on that, we're going to go over to the other network device. And we're going to do the same commands. So NTP, oh, I don't know why I'm trying to type NTP ass. NTP authenticate, NTP authentication key 1 MD5 Cisco, and then NTP server 5.0.0.135 key 1, and then NTP trusted key 1, and we're going to write that. If we do a show NTP associations, no, do show NTP ass. That's the command you're going to want to look at. We're not synced with it or peered with it, whatever the correct wordage of that is. I just went back to core 1, and it looks like we have the star, so we're synced with the NTP server now. And if we do a show clock, there's the correct date, Monday, October 22nd, 2018. So core 1 is now synced with the NTP server. It's going to be pulling its time from there, and its time is going to be correct. And I guess it doesn't do logging by default. Yeah, nope. Oh well, I was going to show you the difference between, or the usefulness of having a synced clock. And that's really so your log timestamps match up. If you see an error trying to troubleshoot an issue and you see a ports flapping, and it's telling you that it was doing it on April 23rd of 1993, you don't really quickly understand when that is. So having a correct time source is pretty good when you have logs and you actually want to be able to understand them. Alright, so now that we got NTP configured, let's move on and configure up a Syslog server. So I know this one is our NTP, so I'm just going to label it NTP.135. Yep. So let's move on to another physical server. We actually could do all of these services on the exact same server, but I'm, for whatever reason, not a big fan of that. I like to do them on physically different servers just to show each service that we're running. But this one's going to be our Syslog server. So let's go to the Services tab and just go ahead and enable Syslog, which it is by default. So now we can set an IP to it. So 5.0.0.136. Next address. Set the mask to a /28. Default gateway 129. And DNS server and 10.10. What was it? 4.1. Make sure we can kind of ping. Let's see if we can ping the DNS server. Whoa, not 104. And there we go. It took 2 timeout pings for us to actually make it through, but we have internet connectivity from this server. So now what we want to do is configure our network devices to send its logs to the Syslog server. And the way we're going to do that is the logging command. And here's our options: logging, IP address of logging host, buffered console host on trap, user info. The options we're going to be concerned with right now is the IP address of logging host. Once we set that to the server's IP, it's going to send logging information that way. Host is kind of just another way to do the same thing. On, to turn it on, that's pretty self-explanatory. And trap, just to set the logging level. If you don't know the syslog messages, what are they called? Oh, is it precedence? Not precedence. I don't know. Level of importance, 0 through 7, with 7 being the least important. That's one of those scales that's backwards. 0 is emergencies, the most important messages you want to see. 7 being your debug commands, not necessarily all that useful, but sometimes you want to see it. So if we just do logging and the IP address of our logging server, which is 5.0.0.136, then we just enabled that server as an offsite syslog server. Next command we need to do is turn logging on, and we're going to set logging trap to, looks like we only have one option, which is debugging, and that's going to send all syslog messages to the server. If you want to filter them out, you would change the severity level. That, I think that's what it's called, severity level down, and you can filter out what messages you want to see. But to do that, you need to know what messages are at what severity level. And that's something for you to look up. And the last one we're going to do is, there is no last one. I was thinking of logging host, but that first command basically did the same thing. So let's write that and do a show run, make sure it got in there. Your syslog information is going to be near the end of your configuration. At least I thought it was at the end of the configuration. Maybe, oh yeah, right here, logging. So we're logging to this server with a level of debugging. Now what we're going to do now is interface fast Ethernet 01. Is that connected to anything at all? Show IP interface brief. So fast Ethernet 01 isn't. So let's do 03. Interface fast Ethernet 03. And we're going to shut and no shut that. It's a quick way to generate log messages is just by shutting and no shutting a port. And moment of truth, let's go to our syslog server, and we don't have any messages. So why don't we have any messages? All right, let's go back here. We're going to do logging. We'll try the logging host command, 5.0.0.136. Put that in there. Do a show run, see if that command looks any different here. Nope, looks the exact same, 5.0.0.136. Let's go back here. We still, oh, no, there's one. So possibly the reason we didn't get that last message is because I shut the interface to the server switch. So maybe it just didn't send it out because that was its route at the time for the server area. It's probably what happened. But here you can see we got a log message from 5.0.0.130, which is, well, I guess it's core 1. And the message was that the OSPF process has loaded. Yep, loading to full, loading done. So that's how you configure Syslog. It's fairly easy, fairly simple. You know, there's not too much to do. You just enable logging on. You set the IP of the host, and then you set your trap or severity level, which in the case of Packet Tracer, you only have one option, and it's debugging, which is going to send all Syslog messages to the server. And I'm just going to change the name of this to Syslog.136. Okay. So that's kind of the quick and easy, down and dirty of NTP and Syslog. You would just copy those commands across all of the devices, have all the devices pulling the correct time from the NTP server, and all devices sending their logs out to the Syslog server. So you'd have one centralized database of all of your logs and the correct timestamps on them. That's the important part. That's why we did NTP. Alright, what other servers do we have to set up here on the server switch? I think, let's just look at the server and see if there's a service we want to do. Ooh, here's a good one. Actually, this might be what it didn't support. No, it should support that. See, I think we've done an HTTP server somewhere. Have we? No, yeah, looks like bitch.tits and email over there. So we've done HTTP. DHCP, it showed you how to set that up. We didn't set up DHCP for this network though. That is something that we probably should do, and that's probably what our third server should be, but I think I'm going to select TFTP because we haven't done one of those yet. AAA is another really good server. Should probably show how to set that one up. Maybe we'll add that one in, and that'll be my second video. Probably set up AAA and FTP, I guess. This radius thing is new to 7. Alright, let's do TFTP. Oh, and the service is already on. So let's just assign this an IP, 5.0.0.137. With the default gateway of 129 and the DNS server. So that's really all the configuration we need to do on the server. You don't set anything up for TFTP really, you just enable the TFTP service. So TFTP.137 is what I'll label it as. And then what we can do with that is go onto one of our network devices, and if we want to back up our running configs, which, I mean, we all know the copy run start, which is copy running configuration to startup configuration. That's not always safe, just sitting there on the switch. Unless you kept a backup already somewhere, you might want to pull that configuration from the switch and keep it in a safe spot in case it catches on fire or something. So we use the TFTP like this. So copy. And we'll say, actually, let's see what we got in our file system first. So directory flash. So usually where stuff is stored. Well, nope, doesn't look like our running configuration or startup config is stored there. So let's do a directory of, oh, it looks like Packet Tracer has these in their own thing. Wait a minute. Let's see. Nope, can't do a dir all on here. NVRAM, there we go, alright. Startup config is stored in NVRAM. So what we do is copy NVRAM. Can we even do that? Oh, that's not an option on here. Usually when you copy it, it's copy NVRAM TFTP, which means you're copying from the NVRAM file system on the device to a TFTP server. Here they've got startup config already as a command. I think you can do this on a real one, but it's not the way I usually do it. So copy startup config to TFTP, and that's all you do. You just state where you're going from and where you're copying to, and then enter. It's going to ask you the name of remote host, so 5.0.0.137, the IP of our TFTP server. Destination file name, core1-config, we're going to leave that the same. And now it's copying the startup config to our TFTP server, and now it says it's done. So if we open up that server we just made and go to the TFTP service, we should say, or see right here, core1 config. We've now backed up core1's configuration file. Now another thing you can do is you can pull from TFTP. So copy TFTP to, we'll say flash. I'll show you another thing after that. Now address again, 5.0.0.137. And the source file name, for this we have to go in here and actually get a file name. So when you're requesting files, they need to have an exact name. Oh, it doesn't look like I can copy it. ASA842k8.bin. They are case sensitive, and you do have to have the file extensions. So this is going, nope, there it is, already done. So what that did was it copied the file or operating system basically for an ASA 842-k8.bin over to our network equipment. And if we do a dir flash, we'll see it right there. And that's useful for upgrading iOS. That's actually how you would upgrade an iOS from a TFTP server. You would have your new version on your server, pull it down to your device using TFTP, and then you would set your network device to boot from the new iOS and do a reload. Now I'm going to do something just to kind of show you one good reason for having this TFTP backup server. Which actually I'm not seeing the core config in here anymore. Did it move? That's weird. It's like it disappeared off the server. Oh no, there it is. Core_1 config. Okay. So if we do a delete startup config, can we not do that? Delete startup config. Delete file name startup config. Yes. Error deleting flash startup config, no file or directory. Yeah, that doesn't exist. Okay, here it is. Erase startup config. That's the command I'm looking for. So yes, I would like to erase the startup config, and now if we reload our core1, you should know what's going to happen. If we don't have a startup config, it's not going to have any configuration to load when we do this reload. So it's just going to be a blank switch when it boots up. Yep, see? Configure or initial configuration dialog. No, we don't want to do that. We're now on a blank switch. Now we do need to have a connection to the TFTP server, which probably I should have thought about that before I wiped the switch, because we're not going to have any IP routes or anything. But what we can do is just configure up interface fast Ethernet 03 with an IP of 5.0.0.1, what was it? 131, I think. Hopefully that's not a duplicate. Whoa, not a K. I don't want that in there. Oh, no switch port. Always forget that command. We'll write that, which was probably a bad idea. So now if we do copy TFTP to startup config, which is really weird to do it that way. Usually what I do is it's copy TFTP to NVRAM, and then you name the destination file name to startup config, not copy TFTP startup config, which actually, to be honest, I haven't tried that on a real piece of equipment, but maybe it works. That's not how I usually do it. Don't know why I'm doing a 10, 5.0.0.137. And the source file name is going to be core_1-confg. And destination is going to be startup config. And there. It says that was copied successfully. So at this point, we're going to do a reload. One of the big mistakes, so I'd say system configuration been modified. Save? No, I don't want to save it. You do not want to do a write. You don't want to do a copy run start. You don't want to save your configuration if you're doing this, because what we're trying to do is restore the old config. And what we did was we copied our old config backup from the TFTP server down to our network device as startup config, and now we're reloading to get those configurations back. So once it comes up, you can see core 1, all of our old configurations are back on the switch. So I think that's where I'm going to end this video. The next one I'm actually going to make like 5 minutes from now. I'm going to try to configure our VoIP router right here, and then try to get all these phones to talk to each other. And this is actually the part of Packet Tracer that I've had the most issues with over the years. My phones sometimes work, sometimes don't. Half of them work, half of them won't. We'll see how it goes. But one thing we do need to do before we get into configuring the VoIP router is we need a DHCP server. Our phones have to pull a DHCP address. I'm not statically assigning them. I think you can statically assign them, but that's not something I'm going to do. So we got to set up DHCP, and then we can mess with the VoIP router. And then I might go into FTP, which is basically the same concept as TFTP, except for you actually have a username and a password to log in with it, and you can kind of look around while you're in there. It's not just a straight, you better know what's out there, shitting of information to and from a server. So it's a little cleaner, but thanks for sticking around for this. Hopefully I can tie up all the loose ends on this series and won't really have this sticking in the back of my mind as something I never finished. So thanks for watching.